Welcome to the AP Calculus AB Unit 1 preview. In this preview, we will go over some of the highlights in the unit plan and then see a snapshot of the lessons within the unit. My name is Jacqueline Worley, but you can call me Jackie. I teach AP Calculus, AP Statistics, and Pre-Calculus at the Hampton campus. Look at how happy I am when doing math. That's because math is awesome. If you need to contact me for a question or to just geek out math only, you can email, call, or text. Take a moment to read our transfer goal from the unit plan. Too tiny? Let's blow it up. This is the exact wording from the AP Calculus course description published on the College Board website of what is expected of scholars for Big Idea 1, Limits. Unit 1 will begin the second week of instruction. You can use my planning calendar provided in the resource bank to see when I plan to teach units and lessons throughout the year. Many campuses require teachers to participate in campus-wide initiatives during the first week of school, which prevents content from being taught. If this is the case in your campus, you do not need to worry about falling behind because certain times of the year have been calendared as flex days, where it is expected that content instruction will not be offered. However, if you are able to use these days to teach content, then use them. I also show the chapter of the textbook where each lesson comes from for ease of planning. If your campus allows you the flexibility to teach during the first week of school, I strongly recommend you use the time to review some prerequisite concepts. If you don't have time up front, you may need to take a few minutes at the start of the first few lessons to remind scholars of their basic math skills. I use my summer math assignment to review prerequisite concepts. My summer math assignment can be found in the resource bank. I will review for about 30 minutes each day during the first week of school. This is a time to knock the cobwebs loose and get back into math for the school year. Some of the important skills included in your packet are interval and inequality notation, graphing a line, write the equation of a line given different types of information, factor, evaluate a function at a numerical value or algebraic expression, or perform function operations. Finding a composite function is particularly important for learning the chain rule in Unit 2. Check out the summer math assignment. These are just a few of the many concepts scholars must know to be successful in calculus. Resources. Teachers have been provided 2 annotated lesson plans for this unit, an investigation for Lesson 3 and a 5-step for Lesson 4. The textbook is used for almost all of the lessons that I teach. There are a few concepts missing from the book where I will create a custom lesson, but otherwise it is a valuable resource to teach the content necessary to perform well on the AP Calculus exam. A library of fluency assessments with multiple versions of each skill has been provided, along with the summer math assignment and planning calendar mentioned earlier. Other items will be provided in the resource bank along with links to useful websites. Notation. Scholars are expected to use proper and complete notation at all times. It is crucial that teachers model this practice. When grading scholars, make sure to take off points for improper use of notation. You're not doing your scholars any favors by being lenient. In fact, AP exam readers will not follow lenient grading practices. The most common mistake I see with limits is what is known as a linkage error. Do you notice the difference between these two problems worked out? The final answer of 3 is correct, but notice the notation mistake. When the AP exam is graded, this scholar would lose a point for improper notation. The limit does not equal a factored rational expression, and the factored rational expression does not equal 3 unless you take the limit as x approaches 2. We can discuss this further at Collaboration Day Kickoff if you are having trouble seeing it now. Just let me know. Vocabulary. Scholars must use proper math vocabulary at all times. If one word is used incorrectly, an entire answer may fail to earn credit on the AP exam. Vocabulary is so crucial. I am not saying that teachers should not use catchphrases to teach tricky content. However, only teaching your scholars catchphrases and never forcing them to use the proper words is handicapping your scholars from earning college credit. Always keep this in mind when asking scholars to answer questions verbally and in writing. When I teach horizontal asymptotes, I always help my scholars remember information by saying Bob, Bot, and Ed. However, when they need to answer a question for me, they must use statements such as f has a horizontal asymptote at y equals 0 because the degree of the denominator is larger than the degree of the numerator. Outcomes. Take a moment to read the expected outcomes of the unit. For such a small unit, there are a lot of skills and concepts the scholars need to take away. Luckily, these skills will continue to be interwoven into the course, giving scholars the opportunity to master them before they take the AP exam. Take another moment to read the remainder of the outcomes. Please note that the intermediate value theorem will most likely not be mastered in Unit 1. In fact, I would not spend a great deal of time teaching it in this unit. This is one of the big tested theorems where scholars will gain a deeper understanding as the school year progresses. This is also a lesson during the AP review where scholars will learn how to use the intermediate value theorem and write a justification statement. Let's take a look at some of the content that are high leverage skills or not as important through lesson snapshots. Average and instantaneous speed are two very fundamental concepts of differential calculus. These concepts will be studied with multiple forms and several different vocabulary words that should direct scholars to similar computations. It is never too soon to introduce these concepts and formulas to scholars. Properties of limits are similar to properties of polynomials. The limit of the sum of two functions is the sum of their limits. This applies to subtraction, multiplication, and division, as well as scalar multiplication and powers. Specific properties of limits. The limit of a constant is always equal to the constant regardless of what x approaches. These properties may be new to scholars. For example, the limit as x approaches 10 of 2 is 2. If there is no variable to evaluate the limit at, then the limit will always equal the constant function. If you want to find the limit of a singular variable as x approaches some constant, then the limit equals the constant that x approaches. For example, what is the limit as x approaches 4 of x? Now we are able to evaluate f of x at 4. I like to tell scholars that when we evaluate limits, our number one goal is to substitute. The challenge comes when we are faced with functions where substitution will result in an undefined value. I cannot stress how important it is for your scholars to understand how limits exist and fail to exist. Be creative, use hand gestures or something else to help your scholars know that if the left and the right hand limits are not equal, then the limit does not exist. Scholars will need to know this concept algebraically and graphically. The squeeze theorem. In a few select cases, typically involving trigonometric functions, we run across a limit that cannot be manipulated or simplified using algebraic techniques. For these limits, we can use the squeeze theorem. Some textbooks call it the sandwich theorem. Scholars have an extremely difficult time applying the squeeze theorem and will never have to refer to this theorem by name on the AP Calculus exam. I recommend that scholars memorize the result of these limits until they learn L'Hopital's rule. To see a list of what I refer to as memorization limits, see the handout Methods for Finding Limits in the resource bank. It would be nice to teach an easier way to evaluate complicated limits using L'Hopital's rule now, but this is not possible without the knowledge of how to find a derivative. L'Hopital's rule will be taught at the very end of Unit 2. Let's move on to Lesson 2. Finite limits means there is a specific numerical value for the answer. When looking for a limit as x approaches positive or negative infinity for functions where the denominator has a larger degree than the numerator, or the numerator and denominator have equal degree, the answer has a numerical value. This numerical value is the same as the horizontal asymptote. There are two commonly AP tested instances that scholars need to be aware of when the horizontal asymptote is not the same numerical value in both directions of infinity. This happens with radical functions and absolute value functions. These are excellent calculator inactive questions on the AP exam. Let's go ahead and take a look at the radical function. So if I created the end behavior model, I'd have x over the square root of x squared. which would simplify to x over the absolute value of x. Not many teachers tell students that when you drop a radical function, it comes out with absolute value, which is why the graph looks the way it does. So now continuing on with our end behavior model, I'd have x over plus or minus x, which equals plus or minus 1. So the limit as x approaches infinity is positive 1, and the limit as x approaches negative infinity is negative 1. If I were to put a negative in front of the function, those limits would switch. Similarly, when an absolute value is paired with a polynomial inside of a rational function, the graph will always have jump discontinuity, and the limits will split to the positive and negative of the same constant as such. Let's take a look at limits that equal infinity. An x value that causes the denominator to equal 0 forms a vertical asymptote. In these instances, it is possible for a limit to equal positive infinity, negative infinity, or not exist. An easy way to find an infinite limit without the aid of a calculator is to create an end behavior model and then draw a rough sketch of the result. Scholars may not be able to sketch this function here, but should be able to sketch a line to figure out which direction the ends are going. So the end behavior model would be x cubed over x squared, which reduces to just x, the equation of a line, y equals x. Any scholar should be able to do this. I would not stress the left and right end behavior model techniques found in the textbook, such as example 8. Example 9 is not needed either. When L'Hopital's rule is introduced, scholars will have an easy way to find the limit of complicated trigonometric functions. Additionally, scholars are not going to recall these methods for finding limits, with so many other high-leverage skills to teach, and because there are other ways to show the skills in these examples, I do not believe it is worth spending your time here. Lesson 3 has been provided to all teachers as an annotated model lesson. Continuity is a concept needed for many of the major theorems in calculus. Scholars must know when a function is continuous in order to know when they can or cannot apply other theorems. In some instances, scholars will have to prove a function is continuous. On the 2017 AP Calculus exam, scholars lost the opportunity to earn points if they did not state the condition of continuity for a theorem. Yes, grading can be very strict. This is an exemplar way to prove a function is continuous. Scholars should be able to prove continuity as I have in red. The given function needs to be evaluated at the given x. The right and left hand limits need to be evaluated and then said that the limit exists because the left and right hand limits are the same. Then the scholar can conclude that because the function value equals the limit, the function is continuous at the given x. All of this should be done symbolically using proper notation, free of errors. FYI, in order to help scholars maintain the skill of graphing, particularly piecewise defined functions, I often ask them to graph by hand. There are ways to graph on the calculator, but I don't share this information with my scholars. If they figure it out on their own, good for them. Types of discontinuity. Scholars must be able to name the type and location of discontinuities. I have never seen a question about oscillating discontinuity on an AB exam, but it is not impossible for this type of discontinuity to show up, so you should teach it. The intermediate value theorem. As mentioned earlier, it is too early in the school year for scholars to truly grasp the intermediate value theorem, abbreviated IVT. You could take a few minutes to introduce the theorem and tell scholars that continuity is a condition for the intermediate value theorem to apply. In short, if f is continuous on a closed interval, that means the endpoints are included, then the intermediate value theorem applies. The intermediate value theorem states, for every input there is an output, which is why the function in question must be continuous. Lesson 4 has been provided for all teachers as an annotated model lesson. Rates of change is a very important concept for scholars to master. The formula shown here for average rate of change is not explicitly written in the textbook. However, this is the formula that scholars must be able to recite in their sleep whenever they read the words average rate of change. Notice that this is the same formula that scholars learned in Algebra 1, the change in y over the change in x. The calculus formula is simply written another way. Average rate of change is used to find the slope of the secant line, in other words, from one point to another. In geometry, we learn that tangent means the line touches the curve at one point. This still holds true in calculus. The slope of the tangent line is the numerical instantaneous rate of change. This formula is much more complicated and scholars will definitely struggle while learning how to use it. It's called the difference quotient. However, there is hope in Unit 2 when derivative rules are introduced. It is important that you do not skip this part of the lesson. Scholars still need to understand this formula in later lessons. As already stated, the slopes of the secant and tangent lines are nothing more than the average and instantaneous rates of change. Here is a nice graphical representation of these lines. I would use this image to explain both lines. Furthermore, the slope of the line normal to the curve is perpendicular to the tangent line, also known as opposite reciprocal. This concept was also taught in Lesson 4. However, I've never seen it tested on the AP Calculus exam. Even so, it's in the course description, so do not skip it. Lessons 5 and 6, review of all topics and the unit exam. I highly suggest providing scholars with review before their unit exam. There are so many concepts and procedures in this unit, and scholars will need time to study. You are responsible for creating your own review. When I create a review, I begin with the unit exam. For every exam question, I create at least one, but normally more review questions. Sometimes, I don't think scholars need more than one, and other times I may add 3 or 4 questions to review for one exam question. When you make your review, keep your scholar's ability in mind. The Unit 1 exam is quite challenging, and as I mentioned with the individual lessons, scholars will not likely master some topics until they have more calculus practice in later units. As such, do not be discouraged by low mastery on the first test. You may want to consider allowing retakes. Included in the resource bank is an activity written by Texas Instruments called, "Is there a limit to which side you can take?" The answer key is also included. Teachers have the flexibility to decide when this activity is most beneficial for their scholars. Use the activity to solidify learning during exam review day. Give the scholars the activity as a take-home assignment. Use a flex day to complete the activity together. It's your choice. I like to send the assignment home, but keep in mind scholars can find the answers with a simple web search. Be careful how you use this assignment for grading purposes. There is also a short literacy component to get scholars started writing about math. One of our focuses in math this year is to get scholars writing. You should take every opportunity to have your scholars write a few sentences, a paragraph, or even a report describing the math content that they are learning and tie it to the real world. You can then use the writing assignment for a grade if you like. Please feel free to reach out to me if you have any questions. I'm here to help you throughout the school year. If you need help understanding a concept or need ideas on how to teach something, please let me know.